x squared equals 1. X is either 1 or negative 1. X squared equals negative 1. X is either I or negative I. But what if x squared equals I? There are two very different ways. One is algebraic, systematic, but tedious. The other is geometric. A single idea lets you solve the problem with your eyes, not your pen, even in seconds. Let's start with the algebra. According to this equation, x cannot be a real number because the square of any real number is always 0 or positive. X must be complex. So, x equals a plus bi. A and b are real numbers. Substitute this into the equation. Compare the real and imaginary parts. From this equation, we obtain a equals b or a equals negative b. In the case of a equals b squared equals 1/2. So here are the solutions. If we try a equals negative b squared equals negative 1/2. It's impossible. So this case produces no solution. In conclusion, the final solutions are like this. Now, put the pen down. Let's solve the problem with our eyes, geometrically. The solution x is a complex number. What does complex multiplication actually do? Here is a complex number z equals r cosine theta plus I sine theta. Multiplying a by z means this. Rotate the point A by an angle theta and scale its length by the absolute value r. This point is a times z. Now, let's apply this idea to our equation. Since x is a complex number, r cosine theta plus I sine theta, scaling x means rotate x by an angle theta and scale its length by r. So, x squared becomes this. The absolute value is r squared and the argument is 2 theta. It's the same as applying the rotation twice. The number I lies at 0, 1 in the complex plane. The absolute value is 1 and the argument is 90 degrees. We want x squared equals I. It means that r squared equals 1, so r equals 1. X has to lie on the circle with the radius of 1, and 2 rotations by theta must equal 90 degrees. Theta is half of 90 degrees, which is 45 degrees. Therefore, this point must be x. The coordinates of this point are like this. This is the solution. But we are not done yet. This is a quadratic equation. There must be 2 solutions. So far, we found the point that reaches I by rotating counterclockwise twice. But rotation can also go the other way. 0, 1 can also be reached by rotating negative 270 degrees. So the original rotation angle must be half of that, negative 135 degrees. This point is symmetric to the first solution with respect to the origin. So the second solution is this. Algebra computes. Geometry reveals. Same equation, 2 completely different ways of seeing. Is there a simpler way to look at it?